Yeah, hi folks. Today I want to go through a few examples of perpendicular and parallel lines and looking at their equations in particular, determining whether two equations represent parallel or perpendicular lines and how we can work that out. This is from exercise 1H, starting on page 49 of your textbook. There are a couple more examples there in your textbook. I'm going to take a couple out of, or just literally take a couple of questions from 4 and from 5 in your textbook, and that's what I'd predominantly like you to work through today. But I'll also set some more questions up on DayMap as well as a bit of an extension. Now, before we get started, I just want to recap parallel and perpendicular lines. Hopefully this is nothing new or not a new concept to you. You should hopefully know that parallel lines, an example of parallel lines could be train tracks. They're the same distance apart no matter where you look at those two lines, and they never cross. Perpendicular lines, on the other hand, will meet at a 90-degree angle, okay, and their gradients will be completely different, and the relationship that they actually have between their gradients is said to be the negative reciprocal. So parallel lines will have the same gradient, as you can see there in that first dot point, the key ideas, and perpendicular lines, when we multiply the gradients together, should be equal to -1. So hopefully you remember back to year 9 linear equations when you looked at the gradient intercept form of a line or an equation. So y equals mx plus c. Remember, m was the gradient or the slope of the line. It was measured as rise over run, remember, and the value of c was our y-intercept. Okay, so essentially, if we're looking at two equations, if the value of m is the same in those two equations, then they'll be parallel, because parallel lines have the same gradient. Whereas if I multiply the gradients of two equations together and they're equal to -1, like that second dot point there, then those lines will obviously be perpendicular. Okay, so I'm going to jump in and have a go at a few examples here. Let's start with, so let's get rid of that, 2. Let's start with question E, question 4E. Oops. Sorry guys, my first time using the interactive whiteboard here as well for a video, so bear with me. Now, we've got two equations there. Y equals minus 3 over 7x, take 1 over 2, and y equals 7 over 3x plus 2. Now the question says, decide if the line graphs for each pair of the rules will be parallel, perpendicular, or neither. So the first thing I can look at is that in equation 1, or m1 equals minus 3 over 7, and in the second equation, the gradient, or m2, is equal to 7 over 3. We can see there straight away that these gradients are not the same, therefore they are not parallel. But we can go a step further. If I multiply those gradients together and they are equal to, remember that second dot point we're looking at here, if they're equal to -1, they're said to be perpendicular. So does minus 3 over 7 times by 7 over 3 equal -1? Okay, if I do some cross multiplying there, cancel some things out. Okay. Well, yeah. Multiply together, they are equal to -1. So, therefore, the gradient of this line is perpendicular. Or the gradients of those two lines are perpendicular. Okay. I'm happy for you to do that on a calculator if you need to. It's a nice, quick, easy way of doing it. Hopefully, well, that's about as easy as it gets. Hopefully that makes sense. So if they multiply together, they equal -1, they're perpendicular. If they're the same, they're parallel. If I jump to example H here in the textbook, so I've got two equations. This time they're not in the format of y equals mx plus c. They're not in that gradient intercept slope. Well, one of them is. This second one here is. It's y equals x plus a half. The gradient of this line, or m2, is... Let's just write that down first. m2 is, what's the gradient of x? +1. I don't know what the gradient in this second line is, so let's just get rid of that stuff so we can see it clearly. The second equation is x take y equals 4. So what I'm going to have to do is a little bit of rearranging here to get it into the gradient intercept form. You can see here. And then if m1 is equal to the gradient of 1, then we know that those lines parallel as well. So, or if multiplied together they equal -1, then they're perpendicular. I might be jumping the gun a little bit. So let's rearrange this equation first. So let's go ahead and take x from both sides. So I now have x, sorry, start again. Now I have minus y equals minus x plus 4. And to get rid of that negative on the right hand side, I'm going to divide by -1 on both sides. Okay, which then gives me y equals x take 4. So now it's in the gradient intercept form here. The value of m, or m2, is in fact +1. Therefore, these lines are parallel. Okay. Now, that's the easy part for today. The second part, or question 5, I want you guys to have a go at, is a little bit more challenging than that, rather. And again, I'm just going to take a few examples from question 5. So, in fact, let's just look at question 5a. It says, find the equation of a line that's parallel to y equals x plus 3 and passes through point or coordinates 1, 5. So, what I'm going to do is I'm going to determine the gradient of that equation. We know that the gradient is +1. So the new equation I'm going to come up with, the equation that's parallel to y equals x plus 3 and passes through 1, 5, would have a, let's in fact write it out, y equals mx plus c. We know the value of m is going to be 1. We know that the line is going to pass through this coordinate, 1, 5. So instead of x, let's put in another 1, because that's the x value from our set of coordinates here. And instead of y, we're going to put in the number 5. So that's the y value of my set of coordinates, plus c. So let's go ahead and solve this. So y equals 1 times 1 is 1, plus c. I want to get rid of that 1, so take 1 from both sides. Okay. And then I'm left with 4 equals c. Well, the value of c is 4. So in the equation of a line that is parallel to y equals x plus 3, the value of c, or the y-intercept, is going to be 4. So the equation will look like this. So blue, y equals 1x plus 4. Or y equals x plus 4. Again, there's no need to have that that 1 there if it's the value of 1. Alright, just like in the original equation. The gradient there is 1, and it's just left off. Y equals x plus 3. Okay? Now that's an easy example again. They will get more difficult than that. I want to go through another example, how to work out a perpendicular equation. So let's go ahead and do that. So let's move down to question F here. So perpendicular to y equals 2x plus 3 and passes through coordinates 2, 5. All right. So first of all, in this equation, m is positive 2. So what is the negative reciprocal of 2? So the gradient of my second line needs to be a negative reciprocal of, apologies, needs to be a negative reciprocal of 2. So it actually would be, if I flip the fraction there, it'll become 1 over 2, and the negative reciprocal would be minus 1 over 2. So my new equation has to have a gradient of negative 1 over 2. Okay, that's a negative reciprocal. And it passes through points 2, 5. So that's again y equals m x plus c. Okay, again, instead of y, I'm going to use the value 5. Instead of m, I'm going to use the value negative 1 over 2. Instead of x, I'm going to use the value 2 plus c. Alright, so let's go ahead and just multiply negative a half and 2. So 5 equals minus a half times 2, which is minus 1 plus c. Then I want to add 1 on both sides. Will give me a value of 6 for c, or the y-intercept of 6. So therefore the equation of a line that is perpendicular to y equals 2x plus 1, the equation of a line that is perpendicular to that would be y equals, okay, we know that the gradient would be negative 1 over 2, so negative 1 over 2x plus 6. Okay. So I want you to have a go at the rest of those questions. Like I said, there's some more examples in the textbook on page 48 if you'd like to have a look at that. Or just use the examples I've done here as a bit of a blueprint to help you work through that. The tough part is going to be, in this first part in question 4, rearranging some of those equations so that they are in the form of y equals mx plus c in that gradient intercept form, so you can easily determine, what is the value of m, and therefore say, yes, it is parallel or perpendicular, or in fact, neither. And then with that, hopefully question 5 becomes a bit easier. You can then look at the equation you're starting with and substitute some values in once you determine what that gradient will need to be. And remember, if it's parallel, it's going to have the same gradient. If it's perpendicular, it's going to have a gradient that is the negative reciprocal. So for example, if a gradient is 2, which is 2 over 1, the negative reciprocal of that is minus 1 over 2. Alright, thanks for watching, guys. Don't forget to hit like on the video. Mr. Johnson drew that. And check Dame out for the questions I'm expecting you to do. Thanks, guys.